All right, good morning, calculus. So if you showed up to class, you would know that class today was canceled, unfortunately, because there was no, or the school Wi-Fi was not connecting, and I know that the same went for some of you guys. You guys weren't able to get into class either, so, no class for today. Instead, you're just gonna watch this video about polar coordinates and conversion, which I kind of wish I had been able to teach to you guys live because, it is relatively important. I mean, yeah, relatively important. It's like a new thing, and I would have been able to answer your questions, but you can still answer questions if you have them. Let's hope the Wi-Fi is working by my office hours this afternoon. Anyways, here's what's going on. Polar coordinates and conversion. So polar coordinates, we see this is our new coordinate plane for polar coordinates. And I know that it looks basically like the unit circle because it basically is the unit circle. So polar coordinates and plotting them. When we have rectangular coordinates, they're going to be x, y. But with polar coordinates, it's going to be r, theta, always. So x, y is rectangular. R, theta is polar. And the r is going to be, well, typically when we see r in math, it means radius. And in this case, it's the same thing. It's the distance from the pole / the origin. So the pole is the point in the center, so the origin. And the theta is the angle that's made with the positive x-axis. So if I want to plot this point 3 pi over 4, so the 3 is my r. So I'm going to go out to 3. So I have 1, 2, 3. And then I'm going to turn this pi over 4. So let's see. Pi over 4 is here. So I want to turn this so it's at that point pi over 4. 3 pi over 4, because that has a radius of 3. It went out 3 from the center, and I turned it pi over 4 radians. So this is my point, 3 pi over 4. So there's A. I'll erase this. Next, I have 5, 2 pi over 3. This should be the same sort of thing. I'm going out 5 and then turning 2 pi over 3. So out 1, so 1, 2, 3, 4, 5. Then turn 2 pi over 3. I believe that's this one right here. And we'll have a point right there. And I can tell that that's 2 pi over 3 because it is on that line with the 2 pi over 3. So there's my point B. Then I want to plot C, which is at negative 4 pi over 6. So if it's at negative 4 pi over 6, there is no need for me to go out 4 first. Instead, what I'm going to do, I'm going to look at this line for pi over 6. So here's the pi over 6. I know it's going to be on this line for pi over 6. If I'm going positive 4, I would go 1, 2, well, I'll use a different color here. I go 1, 2, 3, 4. And that would be my point if it was positive 4 pi over 6. But since it's negative 4 pi over 6, I want to go 1, 2, 3, 4. So we're looking at that line for the pi over 6 and putting a point there. So this is my point C. That is at negative 4 pi over 6. It's on the line for pi over 6, and it's negative 4 away from that pi over 6, which could also be the exact same point as 4, 7 pi over 6. So if we had a positive 4 and a 7 pi over 6. And then I'll look at the last point, which is 3 negative pi over 2. So if I go out 3, so 1, 2, 3, and then I want to turn this negative pi over 2 radians. So if I were to turn it pi over 2 radians, that's the same as turning it 90 degrees, remember for pre-calc. But if I turn it negative pi over 2 radians, that's the same as turning it basically 270 degrees or just 90 degrees in the opposite direction. Dang it. Okay, and then our point is going to be right here. So that's the same as if I had plotted 3 pi over 2. Because I went out 3, I had a radius of 3, and then the radians were 3 pi over 2. So I will actually write that this one could have been, not 7, 4, 7 pi over 6. And this one could have been rewritten as 3 pi over 2. Because those are the same points in the polar plane. All right. So let's find some other ways to represent some other points. So if I have the point 2 pi, so the point 2 pi would be, it would be right here. I'll use a different color. There's my point 2 pi, because it's out 2 radius, or the radius is 2, and it's out pi radians. So if I want to find another way to write this point, well, what if I went 0 radians? What if I'm looking at this line for the 0 radians? And I go -2 on that line. So I could have a radius of -2 if I was at 0 radians. So about -2, 0 would work as another point there. Let's see, what's another one that would work? So maybe I could do something like I did here, where I just turn the opposite direction. So if I go out 2 and then turn it in the opposite direction, in the negative direction, and it just so happens that it is negative pi in that direction. So it could also be 2 negative pi. Or if I wanted to find a third way to represent this, so think back to pre-calculus. Think about how you could just add 2 pi to that to the amount of radians and basically get the exact same thing, because it means a full rotation, because this is 0 or 2 pi. So to get to the original point, we would go like, out 2 and then rotate it pi. So that's how I got my 2 comma pi as the original polar point. But if I went all the way around again back to that point by adding another 2 pi, because going all the way around is adding 2 pi, so that's pi plus 2 pi would be 3 pi. So I could rewrite this as 2 comma 3 pi. So those are 3 other ways to write the exact same point. It could be 2 pi, it could be -2, 0, it could be 2 negative pi, it could be 2 3 pi. So these last 2 points, that 2 negative pi and that 2 3 pi, you would just take that pi, so the theta, plus or minus 2 pi. So the theta in this case was pi, theta plus 2 pi was 3 pi, theta minus 2 pi was negative pi. So that's our first way to get another similar point. You would keep the r and then have the theta plus or minus 2 pi. Or in our other case, we had the theta plus or minus just pi, but the r was negative r. So it'd be negative r theta plus or minus just 1 pi. So the r was 2, so it became negative 2, and then the pi minus pi became 0. So let's try the same thing here. Actually, let me just organize this a little bit. So these are my two ways to generate a new point given one point in polar. So if I have 6, 5 pi over 2, so let's see, I could keep the r and then take the theta and add 2 pi. So 5 pi over 12 plus 2 pi. Well, 2 pi, I can rewrite that as 24 pi over 12. Right, because 24 over 12 is 2. And 5 plus 24 is 29 pi over 12. So 6, 29 pi over 12 is one way to rewrite this polar point. I could also just keep the r and then subtract 2 pi. So I have 5 pi over 12 minus 24 pi over 12. 5 minus 24 is negative 19. Hold on. Yeah. Yeah, negative 19. So negative 19 pi over 12 as an option. Hold on. Oh, yeah. I just got an email from Dr. Ware that internet's out all over the county. Great. So that's my other option, 6, negative 19 pi over 12. And then the third option is if I were to do the negative r, so negative 6, and take the theta and just add pi. So 5 pi over 12 plus pi, well, that would be the same as 12 pi over 12. 5 plus 12 is 17 pi over 12. So negative 6, 17 pi over 12. And if I were to plot any of these 4 points, they would all end up at the exact same point, which is where? 6, 5 pi over 12, that would be up here. So all of those 4 points would end up at the exact same place in polar. And again, this part should mostly just be a review from pre-calc. Remember, you can add or subtract 2 pi to the radians. And yeah. So that's how to plot in polar coordinates. All right. Then let's look at the relationship between polar and rectangular variables, because in this part, we're going to be converting equations from rectangular to polar and polar to rectangular. So I have this diagram here, and clearly this is like a coordinate plane, or my axes there. And let's see, if this is like a point, well, the x value of that point is how far out we traveled. It's the horizontal distance. So there's my x. The y value is the vertical distance. So there's the y. And this is a right angle. I feel like I should mark that. And then if I have r and theta as well, well, r is the distance away from the origin or the pole. So that would be r right there. And theta is the angle it makes. So this right here is going to be my theta. So now if I want to look at the relationship between x, y, r, and theta, you guys might have looked at something similar to this in pre-calc when you did all your trig stuff, because we are getting into trig a little bit with this. So if I'm looking at r, first of all, and I just want to get that in terms of x and y, I don't want to use theta in my equation at all. So for r, which is a polar coordinate, in terms of rectangular coordinates, well, this is a right triangle, and r is the hypotenuse, so I'm able to say that x squared plus y squared equals r squared, because of the Pythagorean theorem. A squared plus b squared equals c squared, where the hypotenuse is the c. That means that r is equal to the square root of x squared plus y squared. And we're able to use that fact. However, I will say that this part here, that r equals x, or r squared equals x squared plus y squared, that is going to be a tiny bit more useful, but both are useful. Then if we're looking at theta, if I want to get theta just in terms of x and y, I'm ignoring the r, so I'll actually ignore the r, maybe not a highlighter was my best choice there. Let's ignore the r. If I just want theta in terms of x and y, so theta is an angle, y is across from that angle, and x is adjacent to that angle. So if I have the opposite and the adjacent, then I'm able to say, think of SOHCAHTOA, back to geometry, the tangent of that angle is opposite over adjacent. So theta is the arctangent of y over x. So that's how to write r and theta in terms of x and y. Now let's look at writing x and y in terms of r and theta. Let me get rid of this. So if I have x, and I want to write this just in terms of r and theta, so if I were to get rid of the y, I'm ignoring the y. So let's see. Again, I have theta, which is an angle. X is adjacent, and r is the hypotenuse. So think back again, SOHCAHTOA. I have the adjacent and the hypotenuse. I'm using cosine. So I'm able to say cosine of theta equals adjacent over hypotenuse, so x over r. So I'm able to say that x equals r times the cosine of theta, if I were to multiply both sides by r there. So x is equal to r times the cosine of theta. As for y, it'll be very similar. Wait, dang it. Not that. Please just, okay, yeah, okay. And then if I want, like I said, if I want the y, I'm going to ignore the x now. So I have the y, which is the opposite, and the r, which is the hypotenuse. So I'm able to say that the sine of theta is the opposite of the hypotenuse, so y over r. So y equals r times the sine of theta. So that's my relationship between the polar and rectangular coordinates. X is r times the cosine of theta, y is r times the sine of theta, r is the square root of x squared plus y squared, and theta is the arctangent of y over x. All right, so now let's look at converting equations from polar to rectangular. And one trick for converting from polar to rectangular, you want to either multiply both sides by r, or square both sides. And that's if it's just like r equals something as your equation. So either multiply both sides by r or square both sides. Either way, it works. And that's, again, if you just have like r equals something. If it's something like, let's see, oh, all these are just r equals. And again, you don't always want to do this. It's really just like figuring out what's going to work. You don't really want something ugly. Like you wouldn't want, I don't know, a trig function inside another trig function when you substitute. But we'll see what works out. So if I have r equals 1 plus the cosine of theta, I would rather not square both sides here. So instead I'm going to multiply both sides by r, which is going to have the same effect here because it's going to be r times r, which is r squared. I'll write that out. So I have r times r is r squared, and I have r times 1 plus the cosine of theta. Distribute the r. So r squared is r times 1, which is just r, plus r times the cosine of theta. And now that I have all this, I'm going to rewrite this in terms of x and y, because rectangular should only be in terms of x and y. Polar should only be in terms of r and theta. Rectangular should only be in terms of x and y. So I have r squared, which I know r squared is x squared plus y squared. I have plus or equals r, so the square root of x squared plus y squared, plus r times the cosine of theta. So r times the cosine of theta is x. And I'm going to leave my equation like that. That's perfectly fine. I know that it can get confusing, like, oh, how far should I simplify this? Or like, what should I simplify this to? There's no real answer to that. If you can solve for one of the variables, go ahead and do it. If you can't do it easily, don't. There's no need to do so. Like on this, I can't solve for one of these variables very easily, so I'm just going to leave it like that. However, if I had just like done it without subbing in, or not subbing in, if I had done it without multiplying both sides by r first, then there's no real easy way for me to get from like that cosine of theta to something rectangular. So yeah, that's why I would want r times the cosine of theta. Let's look at number 2. So number 2, I could multiply both sides by r here, or I could square both sides. There's nothing for sine squared of theta, if I'm looking at like these options up here. But there is something for r times sine of theta, so I would rather multiply both sides by r again here. So I'd have r times r equals r times the sine of theta. R times r is r squared. So then I have x squared plus y squared equals, so r times the sine of theta is y. That's my answer. X squared plus y squared equals y. That is an equation that is in fully rectangular variables. Don't need to simplify it further than that. That's enough. The next one, I have r equals 2 times the cosine of theta. So this one, again, still going to multiply both sides by r. So I multiply both sides by r. And we're going to have r squared equals 2 r cosine of theta. So r squared is x squared plus y squared. And then I have 2 times, well, r times the cosine of theta is x. And I'm going to leave it just like that. X squared plus y squared equals 2x. Again, I know this is confusing. I know that like it can be confusing how far you should simplify, or like if you're doing it right. And there are many like equivalent forms that you could be working with. But, you know, it's no worries if you're unable to like simplify it further than that, because that is perfectly fine. On this one, let's see. I could multiply both sides by r here, then I would have r squared equals 6r. Or if I square both sides, I would have r squared equals 36. And I would rather work with 36 than 6r. So I'm going to square both sides. So I have r squared equals 36. And r squared is x squared plus y squared. And there's an equation that's in rectangular coordinates. That's my answer. On this one, I have r equals 4 times the cosecant of theta. So with cosecant, the only things that we really worked with were tangent, sine, and cosine. So I want to get this in terms of tangent, sine, or cosine. So cosecant, I know that that is going to be 1 over the sine. So this is going to be r equals, well, I guess 4 over the sine of theta. And on this one, instead of multiplying both sides by r, I see that there's that sine of theta in the denominator. What if I just multiply both sides by that sine of theta? Because I know that r times the sine of theta will get me y. So then I would have r times the sine of theta equals, these would cancel out, 4. Or just y equals 4. And there's my answer. R equals 4 times the cosecant of theta is the same as y equals 4. On number 6 here, this one's a little bit trickier. Well, I wouldn't say it's a little bit trickier, but I do want to like manipulate this one a little bit first. So what I'm going to do, I'm going to multiply both sides by that denominator there, just like I did on the last one, kind of. So I have times 2 minus the cosine of theta times 2 minus cosine of theta. So then I'm going to have r times 2 minus cosine of theta equals 6, because these cancel out. I'll distribute the r. So I'd have 2r minus r times the cosine of theta is 6. And now let's replace things. So I know r is square root of x squared plus y squared. So I'm going to have 2 square root of x squared plus y squared minus r times the cosine of theta is x equals 6. And there we go. And again, I know that it's confusing trying to figure out like how far you should simplify it, or when you should keep going, or when you should stop. I even asked Ms. Gilbert about it. I was like, Ms. Gilbert, like, how do I explain like when they should stop simplifying? And she's like, there's no real way to do that. You really just tell them that like, you know, just stop when you want to stop. And if you can keep simplifying easily, keep going for it. If you can't, just stop. So, you know, if we can't keep simplifying easily, we're just going to stop. As long as you get an equation that is in rectangular coordinates, x and y, you should be good. And the same is going to go for converting from rectangular to polar. So for converting to rectangular to polar, there's no real trick to it. With polar to rectangular, you sometimes want to multiply both sides by r, but we saw in like 5 and 6 that that wasn't always the case. But converting rectangular to polar, if I have x squared plus y squared equals 9, well, x squared plus y squared, that is r squared. So I'm able to say that r squared equals 9. And if r squared is 9, then I can take the square root of both sides, and r is 3. Did I have to take the square root of both sides? No. But I did. So yeah. So we could have left it as that, but since I could simplify that easily, I did. Number 8, I have x equals 7. So let's see, I'll rewrite this in polar. So x is r times the cosine of theta. So r times the cosine of theta is 7. One thing Ms. Gilbert did say when I asked her actually was when you're converting from rectangular to polar, you would want to solve for r, unless you can't easily do that. But try to get r as isolated as possible. So here, if I divide both sides by that cosine of theta to get r by itself, well, those cancel out, and I'm just going to have r here. And 7 over the cosine of theta, well, I know that 1 over the cosine of theta is the secant of theta. So this would be 7 secant of theta. And that would be my answer here. R equals 7 secant of theta. For number 9 here, I'm just going to go ahead and start by plugging things in. So I have 4, x is r times the cosine of theta. Y is r times the sine of theta equals 9. And again, I just got those from up here. I will group those r's. So I have 4 r squared cosine of theta times sine of theta equals 9. And I think I'll actually just leave my answer like that. I could divide both sides by 4. I could divide both sides by cosine and by sine, but I'd rather not. I think I'll just leave it exactly like that. That's a perfectly fine answer. Again, there's no real method to getting things the way you want them to be. Number 10, I have x squared plus y squared equals 16x squared minus y squared. So that x squared plus y squared, I know x squared plus y squared is r squared because of this definition right here. So I would have r squared equals 16. And that's x squared minus y squared. We don't have a definition that has x squared minus y squared. So what I'm going to do with that is I have x is r times the cosine of theta. So x squared is going to be r times cosine of theta squared. And then y squared is going to be r times the sine of theta squared. Let's see, let's simplify some things here. So r squared squared is r to the 4th. I have 16 parentheses r times the cosine of theta squared is r squared cosine squared of theta minus, it would be minus r squared times the sine squared of theta. I can pull out that r squared because it's in both terms. So I can do r to the 4th equals 16 r squared cosine squared of theta minus sine squared of theta. And then I can divide both sides by r squared. To get r squared on this side equals 16 parentheses cosine squared of theta minus sine squared of theta. And I will leave that as my answer. R squared equals 16 cosine squared of theta minus sine squared of theta. Okay, and the last one here. So I have x squared equals 9y. So x squared is, well, r times the cosine of theta squared. Come back. Why is it not coming down? Okay, so r times the cosine of theta squared is my x squared equals 9y. So 9 times r times the sine of theta. So let's see, r times the cosine of theta squared is going to be r squared cosine squared of theta is 9 times r times the sine of theta. I will divide both sides by r here. So I have r times the cosine squared of theta equals 9 times the sine of theta. And I could leave it like this, but I'm going to simplify it a bit more. So divide both sides by cosine squared of theta. So the cosines are going to cancel out there, and I'm left with r equals 9 times the sine of theta. And if you don't mind, I'm going to write that cosine squared of theta as cosine of theta times cosine of theta. Now hopefully, from here, we're able to see that this equals, so I have 9 over the cosine of theta times sine over the cosine of theta, sine of theta over cosine of theta. So if I have 9 over the cosine of theta, that's the same as 9 times the secant of theta, because 1 over the cosine is the secant, and the sine over the cosine is the tangent of theta. So I have r equals 9 times the secant of theta times the tangent of theta. And like I said, we could have just fully left it at r times the cosine squared of theta equals 9 times the sine of theta. That would work. That's perfectly fine. But I just wanted to simplify this a little bit more. It's just like those trig identities. It's getting the trig identities into a similar form because, you know, it could be like, I don't know, secant in one problem, but in another problem, it's 1 over the cosine. You don't know what you're going to see. So that's why it's just good to like rewrite them, simplify them, figure out where you can get it to, figure out if you can simplify it more easily. Otherwise, don't. And do you need to? No. But should you? Yeah. Otherwise, here's today's assignment. It's basically just what we did. You're plotting 4 of these points on the polar plane, and then 5 problems where you're converting from rectangular to polar. I did post an answer key already, so that should help. But like I said, you might simplify to a lesser extent than I did, or a further extent than I did. And same goes, well, no, same doesn't go for plotting the points. Your points should end up in the same place that mine did. But, you know, for the simplifying these rectangular to polar equations, you know, you might get an equivalent form. You might get the same thing I did, but yeah. This is why I wish I had been able to teach this lesson, like, virtually to you guys instead of via a YouTube video, because, you know, I would rather not. I'm sure there are plenty of questions on this, and I wish I was able to answer them right now. Unfortunately, I can't. But I do have office hours, hopefully, if Google Meet will allow me to log on. Otherwise, see you guys tomorrow. Have a great rest of your day.